I thought I'd talk a little bit about how a nuclear power plant works. Now, there are a number of different designs, but they basically all work pretty much the same. They're using hot water to generate steam, to generate electricity through turning a turbine. So where does the radioactivity come in? So here is a mock-up of a typical nuclear power plant. Again, there are different designs. And hopefully you can see that there are 3 different sets of tubing. And they are different colors. I've colored one pink, one yellow, and one is black. Now over here, the one that is the pink one, that's in the containment vessel. That's where the radioactivity is. That's the giant cement dome that you see. That's where the bad stuff is. So the actual radioactive source is over here. The radioactive source are in these fuel rods. And these fuel rods contain a radioactive isotope that does what it does best. It breaks down. And as the radioactive isotope breaks down, it generates heat. And we want to make sure that the heat is generated at just the right amount. So we want to make sure that the radioactive decays are happening at just the right amount. That's why they have these things called control rods that can help if the reactor is putting out too much energy, can throttle it back a little bit. Now, again, we have this pink area, this pink tubing that contains water. This water is in contact with the radioactive fuel. So that is radioactive water. You do not want that being released, and you do not want that being in contact with other water. That is why this is a self-contained plumbing system. You see how the tubing that I've labeled pink is all self-contained. Now, if you've ever used a double boiler on the stove to, let's say, melt chocolate, you know that you don't want the chocolate in direct contact to the burner on your stove because it'll burn. So in between, you have a pot of water. You also don't want the chocolate to get watery, so the chocolate sits in one pan, and that pan sits inside the water, and the pan that has the water is what's in contact with your burner. So we have the heat being generated here, but this is radioactive water. So you want this plumbing to be in contact with a second set of plumbing that I've colored yellow. So the radioactivity hopefully is not moving from the pink plumbing into the yellow plumbing. Now that yellow plumbing has water, which is going to receive the heat, but again, hopefully not the radioactivity, from that first plumbing, and it's going to get hot, and the water is going to boil and create steam. And the steam is going to rise up, and it's going to turn the turbine that generates the electricity. Now we need to turn that steam back into liquid water so we can keep the process going. So the steam, after it turns the turbine, is going to be cooled. And so we need this third set of plumbing, which I've labeled as black, to come in from the outside, and that also is not in direct connection, direct contact, because a little bit of radioactivity can get into this second yellow plumbing. So this black plumbing comes in from the outside. It takes away some of the heat. It cools down that yellow plumbing, and then we have the steam condensing into water, going back around and turning the turbine. So what do we do with this black set of plumbing, which has become hot water? Well, we don't want to release this hot water back into the environment because it could affect fish and plant life. So we want to cool this water down. We want to let that heat leave. So we can have these cooling towers where this water, which again is not radioactive, it's just gone in to cool everything down, we allow it to cool back to an ambient temperature before releasing it. Or we can just keep cycling it over and over again. So this nuclear power plant is sort of, again, like a double burner on a stove melting chocolate, but it's actually a triple boiler because we have 3 different sets of water that are not in direct connection to each other. They're just transferring heat. And again, in the middle, we have steam, which is turning the turbine, generating electricity.